universe is not only beyond our imagination in most scales, it is larger than we can conceive. Does the universe have a beginning and an end? And has the James Webb Telescope finally revealed the edge of the observable universe? Since time immemorial, humanity has sought to understand the size of the world we inhabit. We meticulously search for boundaries and truths, and in doing so, our knowledge continues to expand. In the past, the edge of the world was just beyond the horizon. Today, we use telescopes to explore the universe in search of clues that will show us whether our universe is a finite space. Perhaps we have made a decisive breakthrough in this fundamental question with the James Webb Space Telescope. Is there an edge to the universe? This is not a question. It undoubtedly exists, but we do not know if this edge is truly the end of the universe or the beginning of something new. The edge could also be like a threshold leading to another universe or previously unknown dimensions. Our Earth, solar system, and galaxy also have edges, but the cosmos does not end there. Neil deGrasse Tyson is absolutely right in saying that the problem with the size of the universe is in our minds, not in the universe itself. The universe is larger than we can imagine. We can only search for the beginning and the end in terms of distance or time, and we still use relatively modest tools for this. With our telescopes, we currently see about 46.5 billion light years in each direction, meaning we see a total diameter of about 93 billion light years. So far, there is no end in sight, and the mass of stars, galaxies, and phenomena we have discovered in this area is beyond imagination. If it took us thousands of years to explore every corner of the universe we already know, driven by insatiable curiosity, we continue to look further and further. We want to know if the universe has an edge and what it looks like, and the James Webb Telescope should finally show us this edge. The James Webb Space Telescope identifies objects in the darkness. According to the best measurements, we have large, fully developed galaxies. We humans tend to think that everything has a beginning and an end, and we usually think in terms of facts and figures, as well as spatially limited enclosed structures. However, anyone dealing with the universe soon encounters the limitations of thinking and perception to understand the incredible scales of the cosmos. Most of us need to expand the boundaries of our perception. The enormous size of what we have seen so far, the number of stars, countless planets, and the strangest cosmic phenomena force a narrow and limited mind to open up. Astronomers and cosmologists must be among the most unbiased and free-thinking people. But our scientists today must realize that they are still quite limited and that they may have been thinking within frameworks that prevented them from realizing the truth of the universe. The James Webb Telescope now pushes our space explorers to their limits. Theories and truths are shaken, and it is quite possible that our worldview will make another leap, as it did hundreds of years ago when people realized that the Earth is round, not flat. The James Webb Telescope shows us 6 galaxies that are so old and so perfectly developed that they should not exist. JWST was designed to study the dark ages when the first stars formed, but instead of showing us the expected protostars and young galaxies, the telescope shows us rows of perfectly formed and very old-looking galaxies. Are we really looking at the beginning and thus the temporal edge of the universe? And did the dark ages really exist? Or did we humans just imagine them because we did not know the truth? The 6 galaxies are not the only shocking discoveries made by the James Webb Telescope. It also discovered a giant galaxy cluster that existed too early to exist. Millions of galaxies cluster together, and until now, we thought that individual stars formed first, then star clusters, then galaxies, and then galaxy clusters. What does it mean that a galaxy cluster existed when the universe was supposedly still very young? Do you want to tell us about countless galaxies with a redshift greater than 10? Quote by Neil deGrasse Tyson. The problem is not with the universe. The problem is with us because we think we know more than we actually do. It sounds crazy, but the James Webb Telescope still shows us more galaxies from a period long known as the dark ages of the universe. Almost all galaxies discovered by JWST in the early universe have a redshift greater than 10, meaning they existed when the universe was 2% of its previous age, just a few 100,000 years after the Big Bang. These discoveries show us not a dark world, but a universe that looked almost the same as it does today. These discoveries are so incredible that scientists initially doubted JWST's findings, but the telescope's spectroscopy confirmed each result multiple times. Spectroscopy played a crucial role in confirming the distance and properties of extremely distant galaxies. Astronomers use this method to break down the light of an astronomical object into different wavelengths and thus determine the age of the light source and physical properties, such as chemical composition. JWST's results showed that these galaxies are not only very old, but also contain elements and a range of stars that do not fit into a young universe. The temporal edge of the universe is currently moving farther and farther away from us. But what about the spatial edge? Have we found it already, or can we find it? Here we face a paradox, because if we are looking for something in space that exists now, we must see that space in real time. Imagine searching for the walls in a very large concert hall. It's dark except for a few small LED lights, 10 or 20 meters away. You do not know exactly how big the room is, and you cannot see the walls. You would have to personally search for the edges, feeling your way. This option is impossible for us in space because we cannot travel through it personally at the moment. Another option is to have a telescope that allows you to look farther and farther, focusing on bright spots, or in other words, where the LEDs are, because you can see at least a little there. If your telescope is good enough, you might notice the walls of the room at some point. But the trick with the universe is that it moves precisely when we look through our new super telescope. JWST is like the walls of space expanding as you watch. So you must ensure you keep up with the movement of the walls as you develop your telescope's technology and range in space. We face another phenomenon that makes it difficult to search for walls or edges. Light takes time to travel through space. With the James Webb Telescope, we see light that has traveled 4 light years, 100, 1,000, or even 13 billion light years, so we only see the past. Strictly speaking, you also see the past in your room, but it takes light from LEDs 60 or 100 meters away only a fraction of a second to reach your eyes, so here we can say that you perceive space in real time. But the time dimensions in the universe are different. We can already see the nearest star, Alpha Centauri, as it was 4 years ago. Of course, we can say that the universe should have been even smaller 400,000 or 5 million years ago, because it had not expanded that far. Nevertheless, we have not yet found any signs of a spatial limit. Instead, we have found evidence that the universe does not expand at the same rate everywhere. This could mean that our cosmos does not have a uniform shape, but is structured in a way we have not yet realized. The James Webb Telescope ventures into infinity. Have you ever thought it might be a mistake to look for boundaries or beginnings? Perhaps this new era of space exploration wants to show us that we must stop thinking in terms of limited dimensions to go beyond what we have considered true until now. In its own way, the James Webb Telescope repeatedly shows us that there seem to be no limits, even within the universe. Again, the telescope has discovered structures that defy boundaries, and this was not even a search for the edge. James Webb looked at a distant galaxy and found such a massive active galactic center that scientists were astonished. In the center of this young galaxy, just around 570 million years after the Big Bang, a quasar with a black hole 10 times the mass of our Sun was already raging. Black holes that are part of an active galactic nucleus emit an unusually large amount of light produced by the friction of material spiraling into the black hole. Such galactic centers shine trillions of times brighter than the brightest stars. Even in its search for exoplanets, the James Webb Telescope constantly shows us that we must stop thinking in terms of limitations. We must strive for diversity and infinity if we truly want to understand the universe. HIP 65426b was already identified by the Hubble telescope in 2017, but now, thanks to the unique new capabilities of James Webb and highly sensitive spectrometers, we have even clearer data about this distant world. HIP 65426b is a massive gas giant, about 12 times larger than Jupiter. It is located at a distance from its star that is 100 times greater than the distance from Earth to the Sun, more than twice the distance from the Sun to the dwarf planet Pluto. Using James Webb's coronagraphs, cameras, and various filters, this planet was directly photographed for the first time, which is an absolute exception, as most exoplanets are discovered by transiting in front of their host star or through indirect methods. These are just two extremes and two more examples that we must accept the fact that there are so many phenomena, peculiarities, exceptions, and new dimensions to be discovered in the universe that it would be foolish to search for final boundaries or limits. Subscribe to the channel now and be part of every new video.